Now we want to have a look at the second part of physics on current electricity. I have treated part 1 of current electricity, where we define what electricity is, what quantity of charge is, and how they are related, and as well the formula for finding quantity of charge. Now, we want to talk about some terms used in current electricity, and one of them is the word current. What is current? Current is defined as the flow rate of charge. Flow rate of charge. Okay, from this definition, we can bring out a formula, and that formula means current equals to quantity of charge over time. The symbol for current is letter I, capital letter I. And in the previous video, the symbol for quantity of charge is Q, and for time, that is small letter t. So that means current can be calculated with the formula Q over T. Do not forget, quantity of charge is in coulombs. That is the unit of quantity of charge. And the unit of time is what? Seconds. That means we can infer that from the formula, the unit of current, the unit of current is coulombs per second. That is from the formula. But I stated it in the first part of this topic, current electricity, that is in the previous video, that the standard unit, that is SI unit of current, is what? Is amperes. And it can be shortened or symbolized with capital letter A. Excuse me. Anywhere you see capital letter A in current electricity, it is the unit of current, which is amperes. Okay. Now, another thing we need to know is the instruments used for measuring current. Instruments used for measuring current. We have galvanometer. This is a symbol. This is a symbol used on circuit diagram to represent galvanometer. You see a capital letter G at the center of a circle or a box. While we have ammeter with a capital letter A inside a circle or a box. Now, the difference between the two is that galvanometer measures small amount of current, such as 0.1, 0.5, while ammeter can measure bigger current, such as 1 amps, 5 amps, 10 amps. We have different types of ammeter. We have milliammeter. Milli means 0.001. That means it can read up to 1,000th of current. That is 1 over 1,000 of current. So they come in different types. Okay. Now let's talk about voltage, potential difference. Though we have mentioned that in the previous video, we still have to repeat it because we will need them all together in this context. Potential difference, which is also called voltage, is another parameter that is associated with current electricity. I have defined this in the previous video, but I need to repeat it as I said earlier on. Voltage is the work done per unit charge. That is, the work is done to move charge from one point to another in a circuit. But the type of circuit where we use potential difference or voltage is called closed circuit, because we have three different types of circuit which we are moving to now. We have closed circuit, we have open circuit, and we have short circuit. I'm going to mention everything. But for now, note that when you hear potential difference, it is associated with closed circuit. This is the formula derived from the definition. And definitely we can also derive unit from here. Unit of voltage from the formula. From this formula is also joules per coulombs. Joules for what? Coulombs for quantity of charge. But this is the SI unit here, volts. So this one is an equivalent unit. Equivalent. That means if you are asked to state the equivalent unit to volts, it will be joule per coulombs, okay? But if you are asked to mention the unit of voltage, the answer is volts, because that is the standard unit recognized globally. Take note of that. The instrument that is used for measuring voltage is called voltmeter. Voltmeter. And this is the symbol in any circuit diagram. Once you see a letter V in a box or in a circle, it represents voltmeter. Another quantity that we need to mention under current electricity is called resistance. What is resistance? As the word implies, resistance means something that resists, something that opposes. So what does this resistance oppose then? The resistance here opposes the flow of current through a conductor. A conductor is also a resistor here. That means this resistor is a conductor. I'm going to talk about resistor and other form of conductor. So every material, every metal has peculiar resistance. A wire made of copper has resistance that is different from that made of aluminum, and also different from that made of platinum. So that means different materials made of the conductor determines how high or low the resistance is. But mind you, you need to take note of this point. It is important to note that when the resistance of a wire is high, the current that will flow it will be very low, and vice versa. That means when the resistance is very low, the current that will flow it will be very high. Unit of resistance is called ohm. This is a symbol for ohm. When we get to calculation aspect, which is going to be part 3, we are going to discuss, we'll be mentioning ohms. Now, we use resistance box of different types to measure resistance in a circuit. However, this resistance also can be varied. That means we can increase or decrease the resistance in a circuit by using a rheostat. So we can vary resistance using a rheostat, either increasing or decreasing the resistance during an experiment in an electric circuit. But as I said, all metallic conductors will conduct electricity. So the best metallic conductor is silver, followed by copper. Why? That means silver has the lowest resistance, and copper has the next lowest resistance. That is why they will conduct more electricity than any other metal. But can you tell us the reason why silver is not used in manufacturing wire? Why is it copper that is commonly used? You must have heard of copper wire, copper wire. The reason is that silver is more expensive than copper. That is why silver is not used for making wire that we see commonly around us. Now, let us discuss what a conductor is. Like I told you, a conductor can be in form of a resistor. So, a conductor is any solid material that conducts electricity or that allows current to flow through it. So, any conductor can perform the following capacities. A conductor can perform as a resistor, which is what we are going to be discussing under current electricity. It can perform as a capacitor and also as an inductor. These are the symbols for each of them. But as per capacitor and inductor, we are not going to mention that under current electricity because they are meant for another phase of electricity called alternating current electricity. Alternating current electricity. That will be in year 11 scheme. We are going to mention that. Okay. Now, examples of resistor are, we have standard resistor, which is also called fixed resistor. We have variable resistor, which is a rheostat. The next you are going to see will be the table showing all different components you can see in an electric circuit. These are the components, symbols that you will be seeing in electrical circuit. So we have discussed some of them in the previous video, such as these, and these. So by God's grace, in the next video, which is going to be part 3 of current electricity, we'll be dealing with resistors in series and in parallel, and as well we'll talk about Ohm's law. That is about calculation all through. Do not miss it. Thank you for watching.